Hi, I'm Joni Stevens with Agilent Technologies.
And I'm Rod Majors, also with Agilent.
In this video, Ron and I will show you how easy the QueChERS sample preparation technique is to employ in any lab. Right, Ron?
Absolutely, Joni. Although this technique is less than 10 years old, it has revolutionized the manner in which multi-residue, multi-class pesticide analysis in fruits and vegetables has been performed. More recently, the extraction of other classes of compounds from other matrices has also been accomplished. QueChERS is as easy as 1, 2, 3.
Exactly, Ron. The QueChERS name stands for quick, easy, cheap, effective, rugged, and safe. What more could you ask for? Step 1 involves an acetonitrile salting out extraction of a sample in an aqueous environment. Step 2 is a liquid-solid extraction, referred to as dispersive solid phase extraction, or DSPE, which removes the majority of the remaining matrix interferences. Step 3 involves analysis by tandem techniques like LC-MS-MS or GC-MS-MS.
Let's take a walk through the QueChERS technique in order to get a better understanding of what's involved. The first step of this method, acetonitrile salting out, also known as partitioning or extraction, requires the homogenization or grinding of a solid sample. We will accomplish this by chopping and then grinding the sample. For the best extraction efficiency, the sample should be in a finely divided state. Then, weigh a specific amount, usually 10 or 15 grams, of the ground sample into a 50 milliliter centrifuge tube. If your sample is a fresh fruit or vegetable, you are ready to continue with step 1, the acetonitrile salting out or partitioning process. To learn more about using QueChERS with fresh fruit and vegetable samples, view our first QueChERS video available at the link on the screen.
Now, Ron, if the sample is a dry sample, can we skip the chopping and grinding?
You know, it really depends. If the sample is dry and finely divided, like flour or spices, then we can skip the chopping and grinding. If the sample is dry and leafy, sort of like these tea samples, for example, we can skip the chopping and go straight to the grinding step. For whole dried material, such as these dried peppers, we have to chop and grind the sample.
Okay, good to know. For acetonitrile salting out or partitioning to occur, we must have a percentage of water associated with the sample. To provide the required environment, we will add water to the dry sample in order to create the required aqueous environment within the sample.
Let's take a look at an example of a dry sample. In this case, we'll use tea leaves. In general, you will weigh a portion of the amount stated in the QueChERS methodology. Add water to compensate for the difference in weight to produce the required aqueous environment.
There are 3 extraction variations of the first step of the QueChERS method. These variations are the original unbuffered method, the AOAC method, and the EN method. Download the notes that accompany this video to learn specific details like standard operating procedures for each version. Today, I am employing the AOAC version of the QueChERS method, which will require 15 grams of total sample. If I add 5 grams of my ground tea into a 50 milliliter centrifuge tube, I would then add 10 milliliters of cold water to make up the 15 grams.
That would be a good time to add the spiking solution, such as an internal standard or compound surrogates, if the sample is to be used for quality control. We suggest that when you add spiking solution, aliquot a small volume into the sample instead of a large volume. This will facilitate the incorporation of the spike solution into the sample without causing any dilution.
Great point, Ron. Now, before vortexing the sample, we add 2 ceramic homogenizers. The ceramic homogenizers are inert, angular grinding weights. They promote additional homogenization of the sample and help facilitate the extraction partitioning by equalizing variances between individual shaking techniques.
Next, add the extraction solvent, acetonitrile, required in the QueChERS procedure. This will be equal in volume to the weight of the sample. For example, the AOAC method uses a 15-gram sample. Therefore, add 15 milliliters of the extraction solvent acetonitrile. Next, vortex the sample for 30 seconds to a minute. Next, you'll add a pre-mixed, pre-weighed salt packet to the sample in the 50 milliliter centrifuge tube. Then cap and shake vigorously for 1 minute as defined in the QueChERS method. Keep in mind that the ceramic homogenizer does a really good job of enhancing the extraction efficiency. Analytes often transfer to the organic phase in a much shorter time.
After shaking, centrifuge the tubes for 5 minutes at 4,000 revolutions per minute. The resulting sample will show 3 layers. The top layer is the acetonitrile partition layer, containing the extracted compounds. The middle layer contains the solids from the sample, and its thickness will vary based on the original sample matrix. The lower layer is aqueous, containing the excess salts from the extracted salts and the ceramic homogenizers.
Okay, let's take a look at step number 2, which involves dispersive SPE of the extract. This extract, of course, was generated in step number 1. For step 2, we will transfer an aliquot of the top acetonitrile layer containing our compounds of interest to the pre-weighed material in the dispersive SPE tube. The amount transferred will be based on the actual QueChERS extraction methodology. Remember, here we've used the AOAC extraction method. Therefore, we will transfer 8 milliliters of the acetonitrile layer to the dispersive SPE tube.
The dispersive SPE will contain anhydrous magnesium sulfate as a drying agent and up to 3 possible dispersive SPE sorbents. Examples of this include primary-secondary amine, also known as PSA, which absorbs organic acids from the matrix, C18, octadecylsilane, which absorbs fats and lipids, and graphitized carbon black, also known as GCB, which absorbs pigments like chlorophyll. Since we are working with a highly pigmented sample, namely T, we will need to use a dispersive kit that contains graphitized carbon black, or GCB. At this point, we will vortex the dispersive SPE tube containing the extract for 1 minute. Then we will centrifuge for 5 minutes at 4,000 revolutions per minute.
Now that we have centrifuged the extract, we are ready for step number 3, analysis. For LC tandem techniques such as LC-MS-MS, the sample, now in acetonitrile, needs to be diluted, usually with a 1:4 or 1:5 dilution with water, so that it better matches the initial HPLC mobile phase conditions.
An example of this would be taking 200 microliters of the extract from the dispersive SPE tube and adding it to a vial containing 800 microliters of water. Then we would vortex and analyze.
Joni, why is dilution important when using LC tandem analysis?
Great question, Ron. Dilution is important because throughout the entire process, the extraction solvent is 100% acetonitrile. Since we run LC-MS-MS in reverse phase mode, we need to be at a low organic percentage to analyze the sample without introducing chromatographic anomalies.
Right. Now in tandem GC techniques, for example GC-MS-MS, the sample can be injected directly.
The original QueChERS publication was released in 2003. The QueChERS sample preparation technique was validated in 2005 with updates to the methodology in 2007.
Thanks to the pioneering work of Lahote, Anastasiadis, and others, there are validated methods for both the major accreditation agencies, AOAC International and European Committee on Standardization.
There are several things to consider when choosing which of the 3 extraction methods you are going to use. First, determine if you need to follow a validated or existing method. Then choose your extraction salts and dispersive SPE based on the method. If you don't need to follow an existing method, it will be advantageous to determine which extraction salts used in the first step offer optimum recovery of your analytes of interest.
For the second step, dispersive SPE, we're excited to offer the newest modification currently being round-robin tested by numerous pesticide laboratories around the world. The Universal Dispersive SPE Kit offers the best overall matrix cleanup. Our Universal Dispersive SPE Kit contains 4 components: anhydrous magnesium sulfate, PSA, C18, and a small amount of graphitized carbon black. If you would prefer a dispersive SPE suggested specifically for your sample matrix, please visit the link on the screen for more information.
We hope we have shown you that QueChERS is as easy as 1, 2, 3. This approach is considered a just enough sample preparation technique. It is not just for pesticide residue analysis from fruits and vegetables anymore. The QueChERS sample preparation technique has been employed for a wide range of compounds, such as antibiotics, hormones, and drugs, and matrices such as blood, wine, and soil. The possibilities are endless.
Please take a moment to view our downloadable notes, available by searching for QueChERS Video Notes 2011 at www.agilent.com/chem. If you have any additional questions, please visit us on the web at the address shown on the screen. Thanks for watching and best of luck with your sample preparation.